Guys, I'm videoing this from my home office at my house. I'm not going to show you my house because that would be weird. Um, but I wanted to go ahead and work a couple of problems from the worksheet from yesterday. Hopefully, you can get this done in class today. It's looking like because of some circumstances outside of my control, I may not be able to be there tomorrow either, as Isaac is still sick with flu, um, and some things came up. So, a couple of things that I want to go over. I just want to work a few of probably three of these problems from the front of the worksheet. I'm not going to work all of them for you, but I'm going to do one of kind of each type that are on here, so that hopefully you can get examples and finish up. Hopefully some of you are already finished. If that's the case, then you can have a day to work on work from previous homework or another class or something like that. But from the looks of it, it didn't seem like many of you were getting very far. So I'm also going to work two of the problems from the back side of the worksheet because we kind of went over it a little bit, but I want to go over in a little more detail how to find the equations of the polynomials in factored form when we're given the roots, and that's what the whole back side of the worksheet is about. So again, I know I kind of glanced over it, but we were running out of time today, or yesterday, I guess, when you're watching this. So let's get right to it. I've got my trusty whiteboard, and I've got a copy of your worksheet. So I'm going to be working these problems on the whiteboard for you as best I can, show you as we're working along. You can pause it, hopefully, and see my work and be able to follow along and do the work along. So the first one I want to do is number 2. The problem is 2x to the 4th minus 17x squared plus 36. Now, a couple of things that we always want to look for first. We want to look and see if there's a common multiple. We're always looking with these polynomials to factor them first, because that's the easiest way that we can find a factor. If there's an x that is actually common to all of them, that means I can factor that x out, and one of my zeros ends up being 0, which is the easy way to do this first. Of course, with this one, there are no common multiples. There are no numbers that are common to each of the terms. Also, there are no variables. There's not an x on that last constant. So the next thing that I look for, because I want to do synthetic division, because we notice that the degree is 4, which is greater than 2. If it's a quadratic, I'm just going to go ahead and plug it into the quadratic formula to find my zeros that way. But since I have a 4th degree polynomial here, it's probably going to be that I'm going to have to do synthetic division twice in order to get it down to a quadratic that I can actually use the quadratic formula on to find the remaining zeros. So this means I'm actually going to have 4 zeros, whether they're real or imaginary, or real or rational or irrational, being whole numbers, fractions, or square roots. So I'm going to have 4 answers. So I start off. I know we talked about multiplying the first and the last, which is kind of the long way around. I was actually I was going over some of my old papers after baseball practice today, and I realized that there's actually another way, a simpler way, to find the values that are going to be possible for the synthetic division. Before I do that, I have to set up my problem with synthetic division before I start determining what my divisors are. Okay, and the first thing I've got to look at, remember, is I'm looking to be going in descending order by 1 for my exponents. So I've got an x to the 4th, an x squared, and then a constant here with the 36. What that means is I'm missing a couple of terms. And with synthetic division, remember, we have to go in descending order from 4 to 3 to 2 to 1 to the constant, which is x to the 0 power. So with that said, that means I've got to have a couple of zeros in my synthetic division in order to be placeholders for those x exponents that are missing, the x cubed, the cubic term, and the linear term that are not in this polynomial. Okay, so to set up the synthetic division problem, I've got the 2 for the x to the 4th, then there is no x cubed term, so that means I go to 0, and then negative 17, and then another 0 because I don't have a linear term or an x term, and then positive 36. So the coefficients for my terms as they're descending in order in exponents are 2, 0, negative 17, 0, and 36. So I have 5 terms because I have a 4th degree polynomial. And remember, we're wanting to get it down to a quadratic, so we can plug it into the quadratic formula to find the last 2 zeros, which is always the easiest way to do it. Okay, so now, what are my possibilities? I know I told you can multiply the first and the last. That actually adds to the number of possible divisors. So another way you can do it is the multiples of the last term, the constant term, over the leading coefficient. Because remember when we talked about this with the synthetic division last week, we talked about if I have a leading coefficient that's greater than 1, I'm going to end up having a fraction where that leading coefficient is my denominator. So I can actually do the multiples here of all of the multiples of 36 divided by all of the multiples of 2. Well, obviously the only 2 multiples, or the only 2 factors of 2 are 1 and 2, because 1 times 2 is 2. Okay, but then 36 has 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, so all of my possibilities, I can write them out. 1, 2, 3, 4, 6, and then 8 is not, 7 does not work, 8 does not work, 9 works, 10 does not work, 11, 12, 13 doesn't work, and then 18, and then 36. Okay, so all of my possibilities. And remember, on all of these possibilities, I have both the positive and the negative for all of these. So I can use positive 1 or negative 1, positive 2 or negative 2, 3, 4, 6, 9, so on and so forth. And I can also, if I want to, divide those by both 2 or 1. Okay, and you'll notice, oops, here we go, get it over here. You'll notice all of these values that I have that could be divided by 2. Like I could end up with 9 over 2 as being my divisor. Now the likelihood of that is very low, but it is a possibility 9 over 2 could be the divisor. More than likely it's going to be 1, 2, 3, 4, or 6, because 12 divided by 2 is 6, so that's a repeat. 18 divided by 2 is 9, so it could be 9. 36 divided by 2 is 18, so on and so forth. So whenever you have multiplicity like this, normally it's going to be one of these lower terms, but not always. So those are possibilities. I won't give you any problems that end up having those funky fraction divisors just yet, because there's not really any need at this point. However, we're going to look for the divisors. Now, remember with the zeros, I'm not going to multiply times the zeros. I'm just adding those zeros. Okay, so I'm going to try 4 first, because I think 4 is a pretty good, it's in the middle. These numbers kind of look like they're spread out a little bit, so we're going to try 4 first. So 4 times 2 is 8. 8 plus 0 is 8. 4 times 8 is 32. That gives me negative 15. And now we're getting pretty big, because 4 times negative 15 is negative 60, and so now I'm at negative 240. Obviously, this is not going to give me a remainder of 0. And that's what I'm looking for, is to get this remainder to be 0, because when the remainder is 0, that means this number, the divisor, was one of my zeros. So 4 didn't work, and it looks like I got pretty high number pretty quickly. Okay, so I'm gonna cut that in half. I'm gonna try 2, and I've got my trusty eraser. It's actually not a trusty eraser. It's some sort of polymer film or filler for a pillow that my wife was doing, but it was the only thing I'd find to be an eraser tonight. So. All right, so let's try 2. So I bring down my 2, of course, always bringing down that first leading coefficient. So then I multiply 2 times 2 gives me 4. 4 plus 0 gives me 4. 2 times 4 is 8, which gives me negative 9. Negative 9 times 2 is negative 18. Negative 18 plus 0 is still negative 18. Ah, here we go. Negative 36, which gives me a remainder of 0. So this means that 2 is one of the zeros of this polynomial. Okay, so that means x equals 2 is one of my zeros. All right, so now look at what I started with. I started with a 4th degree polynomial. So that means that this polynomial would be third degree polynomial. It's a cubic. Okay? So I'm going to go ahead and do synthetic division again. And this has already been a 10-minute video, so I'm going to go ahead and speed it up. I know that -2 works for this next one, so I'm going to go ahead and work that. 2 -2 gives me -4. 4 minus 4 is 0. -2. Oh, no, that's 0. What am I talking about? -2 times 0 is 0, guys. Sorry, I'm getting tired. So that means I've got -9. -2 times -9 is +18, which gives me another 0. All right, so now what I've got is a quadratic. I've gone from a fourth degree polynomial, and then this gave me a cubic polynomial. And when I did synthetic division again and got -2 as one of my zeros, that ends up bringing me down to, I went from 4 to 3, now to an x squared, or a quadratic. Yeah, it's a quadratic expression. All right, so that means I have 2x squared minus 9 equals 0 is what I have left. Now, there are a couple of ways I can do this. I told you yesterday that we always want to do the quadratic formula, and that works. However, another easy way to do this is, because I just have an x squared term and a number, I could go ahead and solve this, because I can add 9 to both sides, and that gives me 2x squared equals 9, and then I can divide both sides by 2, and x squared equals 9 over 2. I'm blocking part of it. Just like that. Okay? And then I can take the square root of both sides. And that gives me x equals plus or minus 3, because the square root of 9 is 3, over the square root of 2. Just like this right here. Because the square root of 9 is 3, and the square root of 2 is the square root of 2. Now remember, we don't want square roots in the denominator, so we multiply that by the square root of 2 over the square root of 2. So my answer, my roots are 2, -2, and then plus or minus 3 square roots of 2 over 2. Those are my answers, because that is how I ended up with, oh, I didn't finish the problem. 3 square roots of 2 over 2. Okay? So the roots are 2, -2, and then plus or minus 3 square roots of 2 over 2. Okay? Now, if I had done the quadratic formula, which I'll go ahead and do that, I would have had, remember, my quadratic formula values come from here. This is my A, 2 is my A, 0 is my B, -9 is my C. So I could do -0, x equals -0, plus or minus the square root of 0 squared minus 4 times A, which is 2, times C, which is -9, divided by 2. So x equals -0 is 0. I don't even have to write it, so it's just plus or minus the square root. 0 squared is 0. 4 times 2 is 8. 8 times 9. What is 8 times 9? That's 72, right? So that is the square root of 72. Oh, that's 2 times 2. Sorry, because the A is 2. I was looking at that because it was kind of funky. All right, so 36 is the largest perfect square that divides out of 72. So I have x equals plus or minus the square root of 36 times the square root of 2 over 4. Well, the square root of 36 is 6. So x equals plus or minus 6 square root of 2 over 4. Now, once I get here, oh, where am I? Once I get here, 6 and 4 reduce to, a 2 comes out of both of those, so it's 3 over 2. So I end up with the same thing I had down here, 3 square roots of 2 over 2. So using the quadratic formula works exactly the same way. All right? So Let me do one more problem from the front, and then I'll do a problem on the back, and then I'll leave you be so that you can work on your problems. All right, so let's look at number 9. X cubed, this one's pretty straightforward. X cubed plus 2x squared plus 4x equals 0, or f of x equals that. All right, so we're looking for our zeros for this one. This is number 9. Now, again, the first thing I'm looking for is common multiples. And in this case, because I don't have a constant, that means all of my values have an x. So I can actually factor out an x. And all factoring out means is that I'm dividing it out. So I'm left with x squared plus 2x plus 4 equals 0. Now, if I have x times this equals 0, that means if this factor equals 0, then the whole thing is 0, because 0 times 0 is anything. So what would make this value 0? Well, if x equals 0. So anytime I factor out an x or an x squared or 3x to the 4th, that's still going to be 0 for my 0. If I can factor out a variable, it ends up making one of the zeros 0. Okay, so I've already got my first 0 is 0 because I was able to factor out a variable of x. Next thing, look at what I have left. What kind of polynomial is this? Well, it's squared. And what am I always looking to get? Always looking to get a quadratic because I can plug this into the quadratic formula. Now, in this case, I have a trinomial, and I know, just because I've done a lot of these, that this quadratic polynomial is not factorable. There are no two values that I can multiply to get 4 and add to get 2. So that means the only way I'm going to get a 0, or I'm going to get one of my factors, is to use the quadratic formula. Okay, so my numbers, I don't even have to do synthetic division on this one because I went straight to a quadratic. Okay, so that means my a is 1, b is 2, c is 4. Okay, so x equals negative b, which is negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times 1 times 4. All divided by 2 times a, which is 2 times 1. All right, so that's my setup for my quadratic formula. Remember, a is the coefficient for my quadratic, b is the coefficient for my linear, c is my constant. So that's how it's set up that way. All right, so now I have x equals negative 2 plus or minus the square root 4 minus 16 over 2. Just multiplying out, doing the arithmetic. Okay? So then, what I do, PEMDAS, I've got to simplify what's underneath my radical. So I have x equals negative 2 plus or minus the square root of negative 12 divided by 2. Now remember, anytime that I end up with a negative inside my radical, that means my 0 is going to be imaginary. Because anytime I take a square root of a negative number, that means it's going to be an imaginary number. Okay, so I go ahead and bring that out. So it's I times the square root of 4. Well, what's the largest perfect square that divides out of 12? Well, we got 1, 4, 9, 16. Well, 16 is already larger than 12, so I know it doesn't divide out of 12. So 4 is the biggest one that divides out of that. So that's equal to negative 2 plus or minus square root of 4 is 2. So I have 2i times the square root of 3 divided by 2. Now I'm almost there with my answer here. Okay? The only other thing that I have to do is look right here. What do both negative 2 and 2i have in common? They have a 2 in common. And what do I have that I'm dividing by? A 2. So I can actually divide both of those terms by 2. So I end up with x equals negative 1 plus or minus I times the square root of 3. So my 3 zeros, because remember I started with a cubic up here, so I'm going to have 3 zeros. My first 0 was 1 because I factored out the x. My other 2 zeros end up being negative 1 plus or minus I times the square root of 3. And that is how that is done. Okay? Now, Shouldn't take me 2 minutes. Let's go over to number... let's go over to number 13 on the back page. Number 13 on the back page. The instructions say write a polynomial function at least degree with a lead coefficient of 1 that has the given zeros. Okay, so what that means is I have to use all of the information that I have gathered from previous polynomial things that I've done in order to multiply these things out to write a polynomial. Okay, so the first thing I want to do is I want to take these zeros that these problems are giving me and figure out what the factors are. And we talked about this yesterday. Okay, so number 13 says I have x equals -4, and then it says multi 3, like this. These are my zeros. Now what this means is I actually have my 0 is -4 3 times over. Okay, so that means this is going to be a cubic function, cubic polynomial, but my 0 ends up being -4 3 times. So if I were to factor it, my factors would be, well, my zeros end up being x minus 4, x equals -4, and x equals -4. Okay, we talked about yesterday. When I have this, how did I solve to find my zeros originally from factored form? I set them all equal to 0. So I want to get this term right here equal to 0. Well, how do I do that? I'm going to add 4 to both sides. Okay, but what this multiplicity of 3 means is actually that factor, whenever I add 4 to both sides, is going to happen 3 separate times. Okay, so I end up with x plus 4 equals 0 is the factor. So the factored form of this polynomial is x plus 4 times x plus 4 times x plus 4 equals 0, or f of x equals. All right, so this is the factored form. Now what these problems are asking is they want me to multiply this out to write the polynomial of least degree, okay? Which all I'm going to do is exactly what I did on that last test, is I'm either going to use the boxes to multiply or the linear method to multiply these things out, okay? So let's do the boxes first. I can only multiply 2 things at once, so I'm going to do x plus 4 and x plus 4, which gives me x squared, 4x, and 16. So I end up with x squared plus 8x plus 16. Something like this, because, again, I'm multiplying the first term times the second term, x plus 4, x plus 4, x times x is x squared, 4 times x is 4x, 4 times x is 4x, 4 times 4 is 16, but then I add the like terms, 4x and 4x gives me the 8x. But now I've only multiplied these first 2 terms, so now I have to multiply this term by the remaining x plus 4. Okay, so I'm going ahead and do my box there, x plus 4. So x times x squared is x cubed, and then I have 8x squared plus 16x, and then I have 4x squared plus 32x plus 64. So I end up with x cubed plus 12x squared plus 48x plus 64. This would be the polynomial of least degree that has a 0 of -4 3 times over. Okay, so all I did over here is I multiplied x squared plus 8x plus 16, which is what I got from the first multiplication, out into my boxes, multiplied by x plus 4 again in order to get this polynomial right over here. That's the polynomial. Okay, so this polynomial right here is the same as this polynomial right here. This is factored form. This is multiplied out. Okay, that's all we're looking to do on these. All right, let's do one more because I want to get to one that has an imaginary root and show you how to do those. So let's do number, we'll do number 14, it's fine. All right, so my zeros are -2 and I. The number of zeros tells me what the degree is going to be. So how many zeros do I have? I've got 2. That means I'm going to have a quadratic. Okay? Now, excuse me. Again, we're going to set these equal to 0. We're going to set these equal to x and then make them equal to 0 to find out what the factors are. Okay? But in order to do this, I have to remember, what is I? I is the imaginary root. What does it represent? It represents the square root of -1. So I'm going to rewrite I as the square root of -1. So I have x equals -2 and x equals the square root of -1. All right. So this gives me an interesting case. I know what this one is, because this one I want to get set it equal to 0, so I would add 2 to both sides. So the first one is x plus 2 equals 0. So the first factor is x plus 2. Now, when I have a square root, how do I get rid of a square root? Exactly, I have to take the square of it. Just like I had to add 2 to get rid of the 2, I have to do the inverse operation of whatever I have over here. So since I have the square root, I have to square both sides to get rid of that. Which means I end up with x squared equals -1. Okay, but I want to get it equal to 0, so I add 1 to both sides, and I end up with x squared plus 1. Now this is why I said this is interesting, because at first, we said we only had 2 zeros, so we should have a quadratic. However, what happens when I multiply x times x squared? It gives me x cubed. So this is actually going to produce a cubic function. And the reason for that is, remember when we were talking about our quadratics, what happens when I take the square root? This value should actually be a plus or minus. So they actually shortchanged me one of the i's. There should actually, whenever I do this correctly, it should have a positive I and a negative I. Anytime I have imaginary roots, they're going to come in pairs. There's going to be a positive value and a negative value. Okay, so that's why this kind of comes out a little bit different than we thought it was going to initially, just because of the way that square roots work. Okay, so I'm just going to multiply x plus 2 times x squared plus 1, and that will give me my polynomial that I'm looking for. So I'm going to do my box again, x squared plus 1, and then x plus 2. X times x squared is x cubed, plus x, and then 2x squared, and then plus 2. Now I don't have, you'll notice when I multiply this out, I have a cubed, a squared, an x, and a 2, and no common, no similar terms, no like terms. So I just write each of these out. So it is x cubed plus 2x squared plus x plus 2 ends up being my answer. Okay, so that is how you do those on the back side. You set them equal to x, and then you get them to equal to 0, and those are the factors. Then you multiply those factors out, and that gives you your polynomial that you're going to have of least degree with a leading coefficient of 1. All right, pretty straightforward. If you have any questions, feel free to email me. I will be at the house with a sick kid, so I will have my laptop with me. So I will check my email throughout the day. If you have any questions, just say, hey, Coach Abel, I don't know how to do number 6. I got stuck on number 8, whatever, and I will do my best to answer those in a timely manner. Again, more than likely I will not be able to be at school again tomorrow, so make sure you come prepared. I will do my best to have resources there for you tomorrow as well, so that we're not falling behind. All right, appreciate you guys. Make sure you're behaving good for the sub. Make sure you're working and getting stuff done so that we can move forward. Love you guys, and I will see you soon.